Hello everyone, welcome to Tech Era. So moving further in our series, today we are going to discuss about quantum entanglement. So let's harness what Einstein called spooky action at a distance. Quantum technology. Knowledge of quantum mechanics is an indivisible part of the electronics industry. However, in the 21st century, the term quantum technology refers to something even more disruptive and radical. It involves exploiting the properties of individual or a few fundamental particles to achieve revolutionary changes in technology. So coming up to the point, what is entanglement? The basis of the theory of quantum entanglement was first laid by Newton during the discovery of the force of gravity. Later, Einstein threw more light on it, due to which we have been able to know many topics about it. When two objects, say two particles of light, also called photons, are in an entangled state, any changes made to the state of one, for example, its spins, are reflected in the other particle, however far they move from each other without breaking the entanglement. If developed, this property can be used to transmit a message at a very high level of secrecy from one point to another. These particles also depend on spatial properties, and at the same time they do not depend on the distance between each other, seemingly breaking the hard and fast rule of the physics that no information can be transmitted faster than the speed of light. This is the basis of premise that entanglement can enable communication faster than light, which according to the theory of relativity is impossible. For this reason, Einstein himself rejected the phenomena as spooky action at a distance. This unusual phenomenon has application in quantum teleportation, superdense coding, and various other applications relating to quantum computing. Of some interest is how entanglement can be applied to the field of quantum cryptography, particularly quantum key distribution. How quantum entanglement secure data? Entanglement can be used for encrypting data if a sender and a receiver make measurements on a number of entangled particles and then compare their results. After performing the measurements, they use their data to generate a quantum mechanical key that can be used to share top secret information. Any eavesdropper will disrupt the entanglement, ruining the key and causing the sender and receiver to break off their communication. Now we see quantum key distribution, which uses entanglement to secure data. Quantum key distribution (QKD) is a secure communication method which implements a cryptographic protocol involving components of quantum mechanics. QKD works by transmitting millions of polarized light particles, photons, over a fiber optic cable from one entity to another. Each photon has a random quantum state, and collectively all the photons create a bit stream of ones and zeros. But how QKD encrypt? The security of encryption that uses quantum key distribution relies on the foundations of quantum mechanics, in contrast to traditional public key cryptography, which relies on the computational difficulty of certain mathematical functions and cannot provide any mathematical proof as to the actual complexity of reversing the one-way function used. QKD has provable security based on information theory and forwards secrecy. The security of QKD stems from the ability to detect any intrusion on the QKD transmission. Because of the unique and fragile properties of photons, any third party or eavesdropper who tries to read or copy the photons in any way will change the photon's state. The change will be detected by the endpoints, alerting them that the key has been tampered with and must be discarded. A new key is then transmitted. Moreover, since the key generated are truly random, they are protected from future hacking attempts. It is clear that entanglement-based quantum key distribution has great potential for practical implementation. Additionally, using entanglement reduces security concerns arising in single photon-based key distribution schemes. Thus, the application of quantum entanglement to quantum key distribution is a topic of great relevance in modern quantum cryptography research. So this is all about quantum entanglement. Thank you for watching the video. Stay tuned with us and subscribe the channel so you can't miss the latest updates.